So in this video, I'm going to review what a CAGR is, and then I'm going to show you 4 different ways to calculate the CAGR. So let's take a look at the data here. We have a column with the years, and we have a column with our data. And as you see here in the chart, this is the starting value of 1,500, which we have here in 2002. And then over here, the ending value of 2,500 in the year 2013. But you see how the values go up and then back down and then up again. And what the CAGR does, compounded annual growth rate. So we want a percent that would take this 1,500 and across these years increase it at a steady rate until we get to our final value of 2,500. So I'm going to build a second, see our first series here corresponds to these values. I'm going to build a second series to show you how we get that straight line from the first value until the last value. So to start this off, I'm just going to say equals the value to the left, the same starting value, and then I'm going to just substitute in the CAGR formula. Later I'll show you those 4 ways to calculate it. So I say equals this multiplied by, and I'm going to put the next part within parentheses, 1 plus the value that's in I13. Now see, I13 is just one of the ways to calculate the CAGR. I'll show you this in a minute. But so we're multiplying the value above, the start value, 1,500, times 1 plus that compounded annual growth rate. So I press enter, and we get, see on our chart here, now we're starting to get a series. And as I drag this down, you're going to see this line go kind of straight all the way up to the 2,500. So let's just take this and drag it down, and now you see that line is going all the way up, and we see that the first value is equal to the first value here, the last value, 2,500, equal to this value. So let's look at method 1, and that is a text description. So here we have the formula text, and I've just put an apostrophe here because if you have 2010 version, you can't do the function that just simply shows, I think it's called formula text, shows the text of this one. So here we have the formula inside of here looking at this description, and we have to take the last year divided by the first year, and then to the power of 1 divided by the number of years. And then at the end of the whole thing, we just say minus 1 because it would give us 104%. We only want the 4.75%. So here we just substitute in the values, which is nice because you see all of this, and then you just sort of take out last year, put in the cell reference, the 2 different cell references, and then the 11 here is the number of years. Now this is a common mistake people make. They say 12 because they count the number of rows, and of course the number of rows here is 12, but really it's saying how many increments from here when we go like this. So from here to here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's not 12 but 11. And the other way to do it is to say, okay, take this year number, subtract that year, and we get 11. So in the cell below, I've done that here where I say C24 minus C13. This gives us the 11. So you can use the F9 key to highlight various parts of this and see what it does. So highlight this part, press the F9 key on your keyboard, you get that value. Go to the next part, take all of this, press the F9 key, and you see what you get. So now you're getting 1.6 to the power of 0.09 repeating. So then we take all of this, press the F9 key again, we get that 1.04, and then of course finally the order of what it does is the subtraction of 1, and you get the 0.04 or 4.75%. So method 2 is the rate function. So let's take a look here. Here's just the basic text. Let's look inside the formula, and when I click in here you see with the different components below. So this is the number of periods. Once again we have 11, and then in the cell below I just show you that same formula to get an 11 dynamically, this number minus that number. 0 is the additional payments. We don't have any additional payments. This is the amount of the present value that is sort of that we're giving away. And then this is the future value. So that's all you need, and it comes up with the same answer. Here I'm simply saying that method I was telling you about, end year minus the start year. So method 3 is the power function. And what you do here is inside of here you've got the number, and we're just saying the end value divided by the beginning value. So really, I mean, let's just click this again, press the F9 key. Here again you see the 1.6 repeating, or almost 1.7. And that means how many, you take the beginning value of 1,500, multiply it by 1.6 or almost 1.7, and that will give you the ending value. So of that 1.6, we want to reduce it, and we do that by using the power. So 1 divided by the number of years. That gives us this 0.09. And then if we highlight the whole thing here and press F9, we see the 1.04. And of course, at the end, you're always subtracting 1, because say minus 1 to get the correct value. And finally, here's a new way to do it, method 4, the RRI function. Let's take a look. Go in here, we'll press this, and it allows you to show the equivalent interest rate for the growth of an investment, as it says right here. So all you have to do is plug in the three things. The number of years, either type it in or you just do your formula equals 2013 minus 2012. The present value and the future value. And you don't have to enter either one of the values with a negative, and that gives you the proper rate. So in closing, I always say to double check that you've got the correct rate. When you get that initial value, which is the same as this one, you should be able to take your CAGR, your 4.75%, and as you just add a little bit, the value before plus the 4.75%, all the way down, you should end up with the same ending value.